Hey everyone, this is Benjamin from the Zephyr project. It feels like yesterday since we last met virtually for a video about a new Zephyr release. But by now, I think you know the drill. Every 4 months or so, a new Zephyr release is out. And this time around, July 18th, 2025, Zephyr 4.2 is just out the door. And frankly, when a few weeks back I started to look at the changelog to be like, hey, I'd rather gather a few highlights to make sure we have some cool demos and so on, I was like, I'm not sure. It feels like it's been a bit quiet. There might not be much to talk about. And I was really wrong. When I looked closer, it turns out we effectively broke a record during this release cycle with over 800 unique individuals, almost also a record in terms of actual commits. So lots and lots of new features, new hardware support being enabled, and yeah, that's why we are here, right? And so, as always, let's actually pull in the release notes. As always, if you go through the release notes, it's pages and pages of documentation about new changes, like new APIs, new drivers, etc. Please go through it. Whatever is your favorite area and subsystem, make sure you catch up on what happened. But this video here is about some of the really, really noteworthy highlights for which it's going to be a mix of demos and me potentially digressing a bit. But yeah, I want to make sure to cover basically everything that's right here as part of the release highlights in the release notes, and maybe cherry picking a few other interesting tips and tricks, maybe here and there, and a few other things that caught my attention. So yeah, I'm not sure how we do it usually, but this time let's go through those basically in order, right? And so starting at the top, initial support for Renesas RX. By the way, I don't know what is going to be you guys' favorite feature, but please let us know in the comments, the YouTube comments below. There's usually quite an interesting discussion happening in the days following the releases. Whatever it is that caught your attention and that you were eagerly expecting, would be nice to hear from you. If there's something you would like to see in future releases, it would be a nice conversation topic as well. So Renesas RX, quick show of hands virtually. Who knows about the ARM processors and ARM architectures? Right, Cortex-M, Cortex-R, Cortex-A, RISC-V, sure, that's okay, getting more and more traction these days. Extensa, you might not be super familiar with Extensa processors, except if you're using ESP32 devices, among others. Usually, many of them are actually based on Extensa processors, Intel x86, etc., etc. The common denominator, I guess, of all those processors is that they are widely popular and widely adopted and are supported in Zephyr. Renesas RX, I have to be honest, a few months back, I had never heard about Renesas RX. It turns out it is yet another processor architecture, which is not new. Like, I mean, support in Zephyr just landed, and we're going to talk. We are talking about that. But Renesas RX, I think, is at least a decade old, and not making this a commercial pitch in any way. I know a little about Renesas RX, but basically when you do some research, what you will realize, if you didn't know already, is that Renesas RX is basically pretty similar, comparable to Cortex-M, ARM Cortex-M. So you would find sort of pretty much the same range of like really small, really tiny, really power efficient MCUs, all the way to beefier MCUs with way more processing power, a lot more peripherals as well for automotive, etc., etc. So I certainly encourage you to do some reading. It's really interesting to see that there's like this entire world of MCUs powering lots of industrial automation and automotive scenarios and solutions out there. So long story short, Zephyr now supports this architecture, right? And so really, like, we get often during for every release, we would get many new SoCs being supported. Vendors, Nordic, ST, NXP, you name it, add new SoCs, but usually it's based on existing architectures, often ARM or RISC-V. It's not every day that we get a new architecture. So yeah, that's basically Renesas RX. There's only a couple boards as of today. QEMU, which I'm going to demo real quick because I mean it's easy. You can run it on your machine. It is there. It is supported. And if you check out, let's go back at the top level list of boards. What do we have in stock in terms of Renesas RX boards? There is effectively another one. The reason I'm pulling it up is just to make sure that you realize it's not only the CPU that for which we are adding support. It's also all the basic peripherals that you typically need, right? Clock control, interrupt control, and even beyond that, I2C, UART, etc., etc. So I think it's interesting. We can do a really quick demo. It's might not be like super entertaining, but just showing you that the QEMU board works, and also basically an excuse to mention something that happened during this release cycle. Let's actually just build, and I'll talk to it. QEMU, just finding this in my command history here. Basically, I just want to build Hello World targeting the QEMU RX board. Something that we do require when we target a new architecture is, of course, all the architecture porting layer in the Zephyr kernel itself. So that's what the Renesas guys and folks have been pretty busy adding and creating, but it is effectively a new processor architecture for which we also need to compile code, right? It's not ARM, Thumb, or whatever, right? It's really its own architecture, which means we need the tool chains, right? And so you could get the tool chains from Renesas, right? Like their own GCC flavor, etc. Or better, we have the so-called Zephyr SDK, which is a nice, convenient way to automatically source a tool chain that you know will work, that you know will be automatically sort of available in your build path and build environment. So one thing worth noting in my in the command I just ran, and maybe you already noticed, the fact that we are compiling against and using Zephyr SDK 0.17.2, which is a new .dot version that came out this release cycle. And among other changes, updates, and additions, it is adding effectively the RX toolchain, which is why and how we are able to compile. So if you are not familiar with it, this is, again, like I mentioned, that was my excuse to make sure that you, if you didn't update your Zephyr SDK, you are likely still running on 17.0, more likely 17.1. But the West SDK command, please do use it to West SDK install. And automatically, if there is a newer SDK version than the one you already have set up, it will download, unzip, install everything for you. So please make sure you do that. And with that, a couple commands ago, I had built the Hello World. Not necessarily incredibly exciting, but we can run it, right? There you go. QEMU RX. Yeah, that's it. So that's for Renesas. Stay tuned, right? Because it's only the beginning. I'm sure more boards will be added, etc., etc. Back to the release notes. What was number 2? USB video class. You might remember from Zephyr 4.1, one of the new cool kid on the block was USB MIDI class, the ability to effectively turn a Zephyr device into some kind of MIDI instrument. USB video, I think it's pretty straightforward. What that means is that you can expose a video stream, a video feed over like your Zephyr device can expose it to a USB host. So effectively and usually you would use a camera sensor, but it can be anything really. So there is a code sample that as always, you are really, really encouraged to have a look at. This is the best way to get started. And how would you get started? Well, basically, there is lots of boards that do have USB support on one hand, but more and more camera sensors being supported as well. If we just look, so we're still on the 4.2 release notes. Those are all the drivers, all the bindings that were added in this cycle. Video-wise, let's see what we have. There's quite a few, right? And we keep adding more. So video sensors that you would typically attach to a Raspberry Pi Pico or the Sony. I'm not sure if there is a dev kit that comes with it built in, or this might be something that you get also through a Shield. And if I were to be interested in doing some USB video stuff, as a reminder, please do make sure to use the dedicated UI in the board catalog. How many boards do we have that are able to do USB and video? There is quite a few. We're going to use the Nikla Vision in a minute, but there's literally dozens. Not all of them might have been tested, but this is where you can also help and contribute and provide feedback if you happen to have issues when trying anything video or USB video related. Should also mention that video can come through the form of shields. That is an addition in this release, the ability to search shields by capabilities, by vendor, and there's apparently 8 shields, right? So those cameras, I mean, ST, you can easily guess that those would be shields that you would typically hook up to ST dev kits, but there's quite a few others. So lots of options. And how does that look like in practice? This code sample that we were looking at, I basically flashed it on my Nikla Vision. A small set of changes I applied. We're going to see that just now. So the Nikla Vision, this is this guy. It's really tiny, really tiny. There's more than just, so the MCU is, I think, STM32H7, reasonably beefy MCU, multi-core, some sensors as well. Distance sensors, accelerometer. So I took advantage of some of those, and let's see how it works when we end up plugging it to our system. Grabbing the USB cable right here. Lots of live demos as always. So plugging it in right here. It gets power and it gets detected by my system, just like any other USB device, and USB camera in this case. Elgato would be this guy right here. And now we have a new one. How does it look like if I put it on screen? Let me do this just now. Did I press correctly? I did not. Yeah, there we go. No cheating, right? This is me. And you can probably notice a very old school looking, very VHS kind of overlay at the top left and bottom right corners. You have some white overlays, which is effectively the only tweak I made to the code sample, which is reading data from the sensor, and I made no effort as to optimizing anything. So I'm sure the frame rate could be better. It's not bad. It could be better probably, but every now and then pulling data from the distance sensor. There is a time of flight sensor that is supported in Zephyr, which gives you distance here in millimeters. So yeah, my hand is like 30 centimeter away from the sensor, and bottom right, you also have like another sort of visualization, which is this circle growing. The idea here is just to make you realize, if you hadn't already, using USB video class in Zephyr to build just yet another webcam. Sure, okay, have some fun, but you might be better off just buying a webcam off the shelf. However, if you start pulling all the different Zephyr subsystems into the mix, then it becomes way more interesting. Starting with sensors, like I did, you can use the sensor data to augment the video feed, to do some, maybe you do some image processing based on, like, you want to visualize temperature information or whatever. You send the data over USB serial. You can also leverage that, right? The fact that there's you can really easily sort of multiplex and make the most of your USB communication channel. Or, and maybe last but not least, you can also tap into edge AI frameworks, machine learning frameworks like TensorFlow Lite and others, where you do some image processing and like people counting, shape, like object detection, etc. And that also is something you can use to augment and to have a webcam that, just like without requiring anything on the client side, happens to be smart already, and you don't require any driver, any additional, you get the idea. So that's, I think, really nice. Do check it out, right? It's still work in progress, and I think the team is working into sort of like stabilizing the APIs, etc. But a lot has happened over the last few months. Okay, next, Twister power harness. Again, virtual show of hands. Who knows Twister? If you don't know Twister, you're missing out. It is Zephyr's testing framework. We use it a lot for dogfooding and for effectively testing Zephyr proper. You can really well describe all your tests, all their dependencies, etc., and effectively run those tests in your CI, in your continuous integration backends, so that whenever, like, nightly or whenever people do pull requests, you can run tests, make sure you don't have regressions, etc. And the way tests are written is that you are testing pretty much regular Zephyr applications, except that you're using so-called harnesses to sort of have Twister look at the execution of the application to figure out and to assess based on the configuration of the harness, assess whether a test is passing or not. Typically, the console harness would be looking at the console output, looking for, I don't know, like OK as a string being output on the console. Maybe that's your tell that the test is passing. And this is like pretty extensible. So you can have as many harnesses as you'd like. At the end of the day, their job is to tell whether a test passes or not. And then you can consolidate all your test results consistently, right? So Power Harness is new. The way it works and what it does is that the device and the application that you're running, it can look at its power consumption and look for the various phases it goes through in terms of power consumption, detects basically all the power states the application goes through by means of peak detection, and all those stages, all those chunks, you can describe in your test configuration what is expected. In here, what we're looking at is a device for which, after a few samples that we just discarded at the beginning, we are expecting to see first a first step where we can we draw roughly 56 milliamps, and then goes down to 4, and then 1.2, etc. Within a given tolerance, and that's it. And so, granted that you have the associated hardware to do the measurement, and initially what is available is an integration with the STM PowerShield solution, but I'm really hoping that, for example, the Nordic Power Profiler kit will be integrated. It's basically just a matter of hooking up, like usually those power monitoring solutions, they expose some kind of Python APIs or AT commands or things like that that make it pretty easy to integrate into this framework. I think what is it? The Joule Scope, I think, is another one. All those solutions, I hope they will be integrated, but right now this is ST only, but it works really well. So quick demo of how this looks like. Let's pull in the terminal. Yes, so we're going to run basically some tests that already exist and that have to do with checking so-called power management states. So the code that we're going to execute is the code of the test is this guy. It's actually going to be an excuse, yet another excuse for a digression, but a quick detour through Zephyr's tickless kernel. Typically, when you think about power management and your desktop computer saving energy, the way you configure it in the settings of your desktop is after 15 minutes, turn off the display. After 30 minutes, turn off whatever, like those 1, 2, 3 stages of power management. And the way it works is that after 15 minutes, it goes into whatever state, which is okay, that's okay. But in the context of Zephyr, effectively, it's alike to what would happen if you were to tell your laptop, hey, you know what? I know for a fact that I'm not going to do anything for the next 15 minutes. So your laptop or your computer could already anticipate and be like, hey, okay, let's go to sleep immediately. That's the same in Zephyr. The tickless kernel is like, instead of every now and then, every like 10 milliseconds or so, waking up, figuring out whether there's anything to do or not, and then going back to sleep, it's effectively able to know if there's only one thread, for example, like what we're looking at here, that is going to sleep for, say, half a second, then the kernel knows that it won't have to wake up until the next half second. And so based on that, it can make some decisions in terms of entering a given power mode and power state. So that's exactly what this code is testing. And so sleeping and waking up with longer and longer times. And so when I tell, when I have code that says, hey, I want to sleep for 500 milliseconds, maybe what this will do is entering the idle state. If I try and sleep for 1 second, maybe it will enter a slightly more efficient power mode, right? And this is all basically described. I think we have it in the overlay that's right here. Yeah. So those power states are described here, and the test that, for which we were looking at the code just before is here to actually make sure that we enter those states. But the one way to actually make sure that this happens is to look at the power consumption, right? Like it's almost the only way to make sure that you got things right in the kernel and the various hooks in the kernel, making sure you're putting your SoC into the right mode. And so in order to test, one might want to do this manually, right? That would be an option. Yeah, the device we're going to use is this guy. So ST, like I said, you might recognize, yeah, you can tell this is an ST dev kit. On this side, it is actually like on the same device, you have, I would say like a regular dev kit and STM L5 kit. And then you also have the chip that allows you to do power monitoring. So on this side, when I use my USB link here, this is to talk, like to flash my Zephyr application and to do potentially debugging, etc. On this side, like this side, this is like for sending AT commands and or using the GUI that you're looking at to talk to the power monitor and tell, ask for power for samples and be like, hey, what's the power consumption? What's the power consumption, etc., etc. So that's my device right here, and I can like hook up my my tool, and we might actually see the communication, the power monitor telling that it has there's some traffic, and if I start acquisition, yeah, you actually see it, and we can see that the app is apparently going through different states, and I could go and manually look at the chart and be like, okay, yeah, this is indeed X milliamps, tick, test passes, but this is very tedious, right? You cannot really automate it. So the idea of the Twister power harness is that we're going to use the same, like we're going to talk to the exact same power monitor, except that it's going to be scripted. So going back to the terminal, and we're going to use Twister to, yeah, what are we looking at here? Twister takes lots of options, as some of you may know, but here it's actually pretty straightforward. First line right here, yeah, I'm going to run tests that only target this particular developer kit. And actually, I only care about the tests that are in this particular folder hierarchy. And I want to run on actual hardware. I have a file that describes where to find what is the serial port to talk to my hardware. Yeah, one more thing here with the PM probe is effectively configuring the power harness to tell it where and how to talk to my power, my ST power monitor thingy, and then yeah, making sure that we don't spend too much time compiling by means of using no clean. Let's see if the demo gods are with us. All right, so yeah, based on what's in the hardware map, it knows how to talk to the developer kit. It would typically compile the tests, except that here they are already compiled, so we should save a few seconds there. And then it flashes the test to the board. The test runs, and in parallel, the power harness looks at what the power monitor has to say. Here, apparently, it has to say that it's happy. So the test passes, and then there's a couple more. There's 4 in total, and once that's done, hopefully it passes. If not, then we might have a regression somewhere in the SOC code or in the Zephyr kernel. Maybe something might be broken. That's the whole point. Like, you want to be able to, in your lab, to look at those regressions and flag them. And effectively, when you're done, you get the test report, like really similar JUnit sort of test report, where tests that pass, tests that don't pass, you can have more details. And yeah, consolidate that into your backend, look at trends over time, etc., etc. You get the idea. But yeah, I would really like to see this tool be sort of adopted more. It's really, it literally just landed during the release cycle. There's probably a lot more work to polish it and to add support for new monitoring hardware. But yeah, I really like it. I hope that's the same for you. Next, MQTT5. Okay, I don't want to go necessarily into lengthy details about MQTT5 because some of you might not care at all about IoT, about having communicating devices, and yet many of you probably do. So MQTT, kind of the de facto protocol for the Internet of Things, has been around for a couple decades, actually turning 30 probably in just a few years, and originally meant to be really lightweight for back in the late 90s, implementing communication for oil pipelines over satellite. So you can imagine how like some of the design choices that were made back then. So this simplicity was causing also some limitations and was making the protocol sometimes not fun to use, lacking error reporting and things like that. So this has been fixed in the new specification that's been out for many years actually, and it took a while for Zephyr to catch up. I think by adding support for MQTT5, this might be the oldest issue that was closed and tackled for this release. One would need to check to keep me honest here, but it's really nice that it's finally landing. So if you enable support for MQTT5 by means of a kconfig option in your Zephyr application, you end up having the ability to connect to a server or using MQTT5, and you end up having new APIs available to you to make the most of what MQTT5 has to offer. So yeah, if you look at the there's a few code samples, right, available for MQTT. The one I'm going to show real quick is the MQTT publisher, which I only slightly tweaked to really help showcase some of the things that yeah, MQTT 5 make possible. Again, not trying to make it too long, but let's go back to terminal. And we're gonna, I've flashed the application already to this guy being a, who recognizes it. So this time, I think it's a darker shade of blue or a slightly different shade of blue. So that's Nordic. Nordic, more specifically the NRF 7002 DK, which means it's a Wi-Fi developer kit. So that's how we get the connectivity to the internet. And I'm gonna connect to this guy over over serial. Let me make sure I'm going to reset it first. Where is it? I think it's this one. Yes, that's it. So we need to get internet connectivity. Like the sample is here. It's just waiting for internet to come up to start doing its thing. And so for that, given it's Wi-Fi, you would typically need to provide the credentials. There's command for that. Wi-Fi cred, I believe, but Wi-Fi cred also allows you to know Wi-Fi connect, sorry, which where I would provide the SSID and the pre-shared key and whatnot. One, I don't want to show you my password and type it live, but I want to actually leverage the fact that you can actually store the credential right into the device and then ask it to so-called auto-connect, at which point you will be looking at all the credentials that are saved, and if any of them matches one of the SSID that the device sees, then it actually connects. Then it connects, then it does MQTT stuff. Some of the stuff that it does, and that's my brief-ish digression into MQTT 5 land, is it can, as it connects to the broker or the server says and tell the client things it supports, doesn't support, so that the client knows, and that can be useful if you like. I mean, typically you want to save bandwidth anywhere you can, and want to save processing cycles as well. If the broker, the server, tells you that it doesn't support wildcard subscription, then you already know as a client you can keep note that it doesn't make sense for you to try and subscribe using the so-called wildcard mechanism, because that just won't work. So don't even bother, and you know that already. So yeah, and then it does publish to the server. So I'm gonna reset real quick and do the reconnection procedure, because I want to show you what happens as we do connect and switch to Wireshark. So yeah, it's gonna connect. And meanwhile, we're going to switch back to this guy right here, turning it right on. So the MQTT server is actually running on my machine. So we're going to be able to sniff all the MQTT traffic that goes between the Nordic Zephyr dev kit and my machine. So the Nordic dev kit is initiating a connection to my machine, and this is where we would typically see that when we tell the we acknowledge, we tell the Zephyr app, sure, yes, you can connect. This is where we would transmit information such as the things that we support and we don't support, and we saw that right before. We saw maximum topic alias 10. That is something that was sent right here. But that's not the one thing I wanted to show you. I wanted to mention basically the notion of topic alias. When you use MQTT, you typically publish data on a topic, and the topic has a name. The name is typically reasonably long because it's sort of like a path. Here, sensors / 1, 2, 3, 4, 5, 6, 7, 8. With MQTT 5, you only need to transmit this once. Like you connect to the broker, you start sending data on topic XYZ, and you can tell the broker, hey, from now on, I will refer to this topic as topic 1 as like a really short shortcut. And you can see that it's only the first published message that required 131 bytes of payload to be transmitted. The subsequent calls and the subsequent published messages actually only, you basically save 16 bytes. And that's basically the length of the topic that you don't have to transmit anymore. You just use the topic alias. MQTT5, like that's really a digression. It's not Zephyr specific, but it's really nice to see that it's supported. Content type as well. I guess I could have mentioned that as well. When you send data, you can really clearly indicate, hey, this is JSON, this is CBOR, whatever, and we can actually see that Wireshark is smart enough to help us unpack and look at what's in the payload based on the content type that was advertised. So that's that's one more MQTT5 feature. There's a lot more. It might actually make sense for folks to add. I would love to see an MQTT sample in Zephyr that really makes the most of MQTT5 and looks at all the showcasing and highlighting all the nice details. But meanwhile, the API is there, and you're very much encouraged to start using it. Going back to our beloved release notes, we are hey, we might be almost through with the demos. Bluetooth Classic, it's like, yeah, a lot, like if you look at the commits in the and yeah, the list of sort of like the top commits, top authors, Bluetooth Classic has been keeping a few folks really busy. And so yeah, Bluetooth Classic stack now includes support for hands-free profile, for audio gateway, hands-free roles, and a few like, yeah, look at the full release notes. Bluetooth Classic got a revamp and got some great work done. What else? Zbus. I don't think there's anything noteworthy, like new Zbus features that landed, but we could actually double check in the release notes to make sure I'm not missing out on something. But the reason Zbus is called out is in the release highlights is due to the fact that it's effectively been around for quite a while. 3 years, if not more, like many releases. It's been there. It's been adopted by many. Like in Tree, there's quite a few places where it's adopted. Out of Tree as well, like many downstream users, and effectively the API is de facto stable. Like it's and the maintainers, the Zbus maintainers, have been treating it as if it were stable to actually make sure to not break people. So we are sort of like acknowledging that, and Zbus effectively graduates. Now you are, you know for a fact that it won't. Like the API, the maintainers are committing to maintaining the API and to not introduce any breaking changes. So there's that. Check it out. And by the way, the Zbus documentation is really awesome, and the code samples and so on. So do check it out. It's actually also interesting to make some parallels with what MQTT has to offer. It's different and yet similar in a way. And one thing that I wanted to call out, I will make sure to include the links in the video, is the survey that Rodrigo, Zbus leader and maintainer, and the Zbus community, they are looking at getting your feedback in terms of adoption and things that you really like and use the most in Zbus, things that you find and identify as pain points. Yet another survey, you might think, but it's really, those surveys are really important for the community to get data points and to make sure that the roadmap for Zbus 2030 and beyond goes in the direction that people do care about and people do need. So yeah, make sure to take a moment to look at this Google survey and fill it out. It should be only a few minutes. With that, this is the time where I hopefully don't digress much more, but go into some of the additional things that might be interesting. I think I mentioned and I've shown the board catalog just before to go through Renesas RX. As I was going through that, yeah, I was showing you the shields. Did I? I think I did, right? So you can now search for shields, shields that support, I don't know, like stepper motors, for example. That's there's a lot, like video is really active. Stepper is also really active these days. And so I think those two shields, I know those two shields were added during this release cycle. So you can search for shields based on the capabilities you need, and then get to the documentation, find the nice snippets that help you get started with them. Yeah, and there's like really lots of cool new drivers also being added. Do take a moment. I usually don't want to. I want to make sure to not offend anyone. Like, as you can see, there's a lot that's happened, but usually what's particularly, I would say, entertaining or interesting is looking at sensors, because there's really like just a ton of variety of sensors for doing lots of different, for sensing different physical quantities, right? And I think this one is a heart rate monitor sensor. Is it? No, this one is energy meter, right? So that's interesting. So measuring energy. One of these is heart rate. I swear, might be this. No, this one is magnetometer. Anyways, you get the idea. It's usually quite fun. This one guy right here, I want to pull a quick demo actually. This is a gesture sensor, so not your typical temperature, humidity, something slightly different. And it was added also during the release. And I want to show a quick demo of this guy combined with stepper motors. So give me a minute and I'll be right back. Yeah, all right. So the demo is stepper motor generic sample. So that's the stepper motor. That's the shield that I'm using, Microelectronica Stepper 19, which we were looking at before, an ST dev kit, a gesture sensor, the PAJ, whatever that we were looking at. And the way it works, granted that the lights in the ceiling don't confuse the sensor too much, is that you approach your hand, it starts spinning, and then you do some gestures. You should be able, yeah, that part doesn't work, but when I turn and counterclockwise, it should start turning counterclockwise. It doesn't, but yeah, like now it does. I mean, you get the idea, and I should be able to stop it as well with like dedicated gestures. Yeah, so that's, well, one, that's fun. But one thing that I want use this as an opportunity to, yeah, I want to show you something. Like, as a reminder, if you haven't used shields in the past or in the recent past, what I'm telling my build system is that the main board I'm targeting is this one, Nucleo board. That's the code sample that I want to build. And then I want to use a bunch of shields. In my case, I'm using the first, the Arduino Uno click, which turns like the blue thing here is the first shield that on the dev kit takes like is hooked over the Arduino connectors and then expose those micro E connectors, and then through the micro E connectors I use the Stepper 19. And then, so yeah, that's my app. And one thing that's new in Zephyr 4.2 is when you build an application, one of the key and central elements in a Zephyr application is the Devicetree, right? Based on the board that you're using and what SoC that board is pulling and what peripherals it's declaring, plus all the overlays you might have in your application through shields, etc. You want to look at what's like the final Zephyr DTS. You're never sure like in what order the overlays are applied, etc., and why such or such value might be set in a Devicetree property. So the Zephyr.dts file for this application is here. So that's my full Zephyr.dts for my Nucleo dev kit plus the first shield that stacks on top of it, then the other shield, then any other settings or like overlays rather than I might have applied through my application. And actually we can see already some interesting things, like apparently in terms of aliases, most of them are being defined at the board level, but then the shield also comes with its own alias. And that alias is actually quite convenient because that's what makes the sample just work out of the box. And then if we keep going down to, let's see, maybe the I2C section, and hopefully I'm not past it. Here, for example, my apparently hooked up to this I2C peripheral is my stepper motor. The stepper motor comes from the shield, right? Like that's expected, but it's nice to be able to see that. And the PixArt, the gesture sensor apparently, and we could look at the code, the way I did it is by means of an overlay in the sample application. So that's an overlay that I added, but we know really, really clearly what comes from where. And I think that's really, really useful feedback. I'm pretty sure what's helping power this nice developer experience improvement is also going to be leveraged in future releases to improve even further, like things like compilation error messages and etc. Because we know, we hear the feedback. We know that this is something that people typically struggle with. All things Devicetree can be sometimes a bit obscure. With that, I think that's a wrap, right? New boards, new shields. Please do go through the immense list of new drivers. I didn't count, but yeah, across the spectrum, auxiliary display for GPIO. I mean, yeah, there's no point in enumerating all of those. It's really, really impressive. Again, it's a record, sort of like record release in terms of number of contributors. I hope people like maintainers, contributors, you watching, you all enjoy some summer break. And we will be back in a few months for Zephyr for the 3. By the way, I would love to hear from folks. Well, one, if you liked the video, make sure to say so in the comment and like the video on YouTube. Would love to hear also what people think about the fact that we do releases every 4 months. Should we do less potentially? Like, does it really make sense that we release that often? Many big open source projects out there, they do yearly, like every 6 months they do a release, and that's already plenty in a sense. So if folks have thoughts and feedback on that, sure, just shout it. We would love to hear that. We will meet you all not all, but many of you, I hope, in Amsterdam in a few weeks for Zephyr Developer Summit. And with that, that's a wrap. Thanks for watching and see you next time.